Okay, going to show you the Whaler bars are put in. These Whaler bars are kind of an oval steel piece. They feed through these X series snap ties. That's all there is to it. The whole function of this whole thing here is to prevent the wall from literally exploding or pushing itself apart. These stand between the internal part of the wall. So when you fill it full of concrete, pretend the concrete's water. It keeps putting pressure more and more and more on the outside of the plywood. And if it gets half a chance, it will break. These connection pieces here are not particularly structural. Their whole purpose is just to hold the edges together. You can get force pulling it like this, but it's not normal or correct to build it that way. You only want to have force expanding, which is normal for properly set up form boards. These plywood sheets are sitting flat on the footing all the way along. So the only force that will actually happen with this wall is expansion. You may get a little sway. You do brace the top of the wall form in. This is just covering a hole. This is the right height for the pipe. This is not the right height for the pipe, but I learned something. This box up here is a chute for the concrete delivery inside the wall system itself. This is filling in the blank for the corner of the house. So we drop the concrete in here. The level of this is at or slightly above the height I want the concrete to be. You'll be able to see it right away because either it'll spill out of the top of the form, which is not necessarily good, or it'll come up to the top of the form on the inside. When you pour the concrete, you should vibrate it. Make sure you brace the wall section really well before vibrating it. In essence, that's it. Whaler bars, snap ties. The only thing I haven't really shown you too much, which is almost impossible to see here, is around the other side, I've got the conical style ties. The two of them generally don't work together, but as I mentioned to you before, you can intermix. The conical ties use 2x4s to actually press against the form, and you lock the head of the conical tie in. Stick with the X series snap ties, they're the easiest ones to use. We're waiting for the concrete truck to arrive right now. I'd like you to look at what I've done here. This is pouring, as I mentioned before, an existing wall form. We're pouring it actually underneath the house. The gentleman who built this house did not finish this corner. He dug out a traditionally shallow basement, and I'm putting in the last part of it, which he never completed. You can have a quick look. We've got X series flat snap ties. We've got a 2x4 reinforcement along the top. I built a chute. The top height of this chute is at the same level as the wall forms. So when the concrete reaches the top here, it should be also even with the top of the wall form on the inside. I realize concrete doesn't flow purely like water, which is why I'm getting plasticizer added to the concrete, which makes it run like crazy. Never add water to concrete. Do add plasticizer if this is the method you're going to use. You should vibrate the concrete during the pour. Vibration allows for it to smooth out and run in either way. The other way, if you're using a 6-inch slump, is to tap the wall forms. It helps the concrete even out. It won't produce a perfect level top. It'll come extremely close, which is all I'm looking for at this point in time. You do reinforce the chute. I built it out directly from the wall form itself. Braced it to my walkway here, and the walkway is further braced to the ground, so it can't give up this direction. Never underestimate the strength of concrete in terms of weight. When this chute's full of concrete, or his chute's sitting inside of it for the dump, tremendously heavy. This is why I've done the reinforcement. It will be good. It's all plywood, it's all been screwed and glued together. The load goes straight down. It shouldn't give up at all. I've got a cut through for a pipe. That's just to allow for our kitchen water to get out of the sink. There's no actual sewage coming through that point. Always overbuild the pipe size. I've got a 4-inch PVC pipe coming through as where the concrete's going to pour directly around. You should always have stress relief, meaning that a pipe within a pipe is a correct way to go. That's what I was going to say here. Oh, it's sloped downwards. Any opening you make in a concrete wall, absolutely do slope it downwards. That way if it rains and it gets wet and there's water running down the wall, it'll hit the pipe, go around the pipe and not go into the basement, flow around it. Of course, you should seal off the pipe to the other pipe. Of course you should, no question about it. You can do caulking, there's a number of different things you can use. But sloping it downwards. If you're making a hole for wires or anything else, same scenario, have it slope downwards. That way the water hits it like a shingle, continues to roll down the outside of the wall, the footing or foundation here, the wall. Reinforce the corners. These commercial conical ties work by putting a wedge device behind it. So you actually wedge the 2x4 against the wall, and then I further reinforce it since I'm mixing my ties and it's very uncommon to do that. Screwing, pre-drill and screw off all the corners all the way down, extend the board across, and I've used 4-inch screws into the plywood sheeting itself. That pulls the sheeting even. I've also got those pieces of plywood which also pull the plywood even. This just reinforces the corners, why I've extended it back like this. Also, what you may be able to see here, I've used steel reinforcement on the outside corners, 14 gauge steel. I don't know the exact length, say 12 inches, all the way down. The bottom is the most important point. That's where most of your load and stress goes. So I've reinforced this corner like crazy. On the inside, I've watched my lapping. Lapping will be this inside of the wall is like this. I've lapped it like this, so it sits on this point here. I've run a strip of wood down the inside, screwed and glued on, and then I've ran my internal 2x4s up to that strip of wood that's running down and screwed it into the wall section itself as well, so you've got double reinforcement, so you can't push back. Now we've backfilled here to beat the rains, or a lot of rain that was coming at us, and hail. We got this all filled in. If you keep the wall wet, it hydrates or cures to a higher strength. It's worth it. The same is true with sidewalks, but the same is true with the wall. This was covered with form releasing agent, diesel. Ordinary diesel works really well on the inside. That maintains the moisture level on the inside of the wall section. The only other detail you should probably know is to get rid of these things here, you strike down and they break. That one's broken. And you go along and do the same thing for all of them. They're designed to break off that direction, not this way, but straight down. You break them off, you pull the metal bars out of here after that point in time, and the wall's pretty much done.